p-value. The p-value is used to measure the significance of the observational data. When we identify an apparent relationship between two variables, let's say we think there's a relationship between shoe print length and height. There is always a possibility that this correlation might be a coincidence. The p-value helps determine if the observed relationship could arise as a result of chance. The larger the p-value, the more likely it could arise by chance. We want the p-value to be below 5%, which is the same as 0.05. In this chart, the p-value is for the slope, and that is definitely bigger than 0.05 or 5%. That's actually 29.37%, which is very high. Because of that, we really don't know if there is a correlation. Interpreting a p-value from the previous example, the p-value of 0.294 is high. It shows there is a chance of getting a linear correlation coefficient of R equals 0.591 or more extreme by chance, even though there is no linear correlation between the two variables. That p-value is too high. But if we go to the one where we had 40 points and look at my p-value, it's less than 0.05, which means that it's very unlikely that this happened by chance. And look at my correlation coefficient. It got bigger, meaning it seemed to become more linear. And my p-value is very small, which means there's a very low chance that it happened by accident. Interpreting a p-value from the example where n equals 5, because the likelihood of getting R equals 0.591 or a more extreme value is so high, it's at 29.4% chance, we conclude there is not sufficient evidence to conclude there is a linear correlation between shoe print length and heights. If I went back to here, I had 5 pairs of data for the one that I used. So I would come here to 5. My critical values, 0.878 and negative 0.878. Let's put 0 here in the middle. And my R value was 0.59, which is between my critical values. And when they're between the critical values, as we can see, there's no correlation. Here, because our p-value is so small, we have sufficient evidence to conclude there is a linear correlation between shoe print length and height. For a data set of brain volumes, centimeter cubed, and IQ scores of 8 males, the linear correlation coefficient is R equals 0.277. Use the table available below to find the critical values. There's my table, and I have 8 pairs of data. I have my number line. I have 0.707, 0, negative 0.707. We always have the plus and minus. And my R is around here, 0.277. First, we put in the critical value. We put in either 0.707 here, and then you can put a comma and minus, or you can use this little plus minus, which means I want the positive and the negative of that value. Since the correlation coefficient R is between those critical values, 0.277 is between the critical values, there is not sufficient evidence to support the claim of a linear correlation. Remember, no correlation between the two values.